Additional naming and drawing practice. 1,2-dichloropropane. I'm going to start by drawing propane. The skeletal structure of propane looks like this. It's 3 carbons. Remember, there's a carbon at every end and bend. Then I'm going to put a chlorine atom at carbons 1 and 2. So that will put a chlorine here and a chlorine here. So that is 1,2-dichloropropane. Now it's just as correct to label this carbon 1 and this carbon 2. They are identical molecules. Pentane. Pentane is a carbon chain that has carbons and hydrogens, and there are 5 carbons. Pent is for 5. So we have 1, 2, 3, 4, 5 carbons here. 2,4,5 trimethyl-octane. I'm going to start with the octane, and I'm going to make 8 carbons. So here's 1, 2, 3, 4, 5, 6, 7, 8. So there's my 8 carbons. And I'm going to leave them numbered like this. 2,4,5 trimethyl tells me that I have 3 methyl groups. One is at carbon 2, one is at carbon 4, and one is at carbon 5. So that is 2,4,5 trimethyl-octane. Now you don't necessarily need to leave these numbers here. It's there for illustrative purposes so that everybody can get used to how the carbons are numbered. 1-bromobutane. So I have 4 carbons in a chain, and then on my first carbon, I'm going to put my bromine atom. It is just as correct to put your bromine on this side. That can be carbon 1 as well. The next one, 4-ethyl nonane. So I'm going to start with nonane. That's 9 carbon atoms. There's 6, 7, 8, 9. Just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. And on the 4th carbon, I'm going to put an ethyl group. So to show an ethyl group, I would do this. This is 1 carbon, this is 2 carbons. So that is the skeletal structure for 4-ethyl nonane. Now I'm going to draw 2-bromo, 3-ethyl pentane. So I need my 5-carbon backbone for pentane. Then I need a bromine on carbon 2. And on carbon 3, I need an ethyl group. So it would look like that. 2,4-dimethylhexane. So here's my hexane. Carbon 2 gets a methyl. Carbon 4 gets a methyl. 2-methylbutane. There's my 4 carbons for butane. Here's my methyl. So that is 2-methylbutane. Cyclohexane. To draw cyclohexane, we would draw a hexagon. Remember, there is a carbon at every end and bend. In each of these angle points is a carbon. So there's my 6 carbons for the hexane. Cyclo means it's joined in a ring. 3-methyl, 4-ethyl heptane. 1, 2, 3, 4, 5, 6 for heptane. So on carbon 3, I'm going to put a methyl group. And on carbon 4, I put an ethyl group. Now I'm going to name from drawings. When you go to name from drawings, you start by finding the longest carbon chain that you can hold your pen or pencil down on without breaking. So here is my longest carbon chain. That's going to be my parent chain or my backbone. And I'm going to count. So I have 1, 2, 3, 4, 5. I have 6 carbons there. That means I'm going to start with hexane. Now I need to name and number my substituents. I have a 2-methyl. I'm going to write them over here on purpose. And I have a 3-bromo. Now I know that it's 2 and 3 because if I go the other way, if I number it the other way just with my green numbers here, 1, 2, 3, 4, 5, 6, then my substituents would be 4-bromo, 5-methyl. Because 2 and 3 are less than 4 and 5, we're going to go with the original way. So 2-methyl, 3-bromo, but how do we order that in order to name it? Well, this is where we use our alphabetical order. So this would be 3-bromo, 2-methylhexane. Now for the next one, again, I'm going to find my longest carbon chain that contains my functional groups or substituents. And in this case, it looks like I have 8, but let's count that. 1, 2, 3, 5, 6, 7, that is 8. That means I have an octane here. Now I need to name and number my substituents. I have 2 methyl substituents and they are on carbons 2 and 4. So this would be 2,4-dimethyl-octane. The next one, again, finding that longest carbon chain, which could be called the parent chain or the backbone. And this time it looks like I have 5 carbons. 1, 2, 3, 4, 5 carbons. Now I numbered it this way instead of from the left. And that's because both of my substituents are over here on the right. So I have a pentane. And this methyl group here, this is a substituent. So it is, you would not name this as a hexane. This is a pentane. Now I have a methyl group at carbon 2. And I have a chloro at carbon 1. Again, with our alphabetical order, this would be 1-chloro, 2-methylpentane. The next one with our alphabetical order, not our alphabetical order, first we're going to find our longest carbon chain. Now, which way do we go? Do we go up here or do we go down here? And the answer is it doesn't matter because they are the same length. So one of those is going to be a substituent and the other one is going to be part of the backbone. And it doesn't matter which one. So I number to find out how many carbons I have. I have 7. That means my parent chain or my backbone is a heptane. Now I have 3 substituents. I have a methyl group at carbon 2. I have a fluoro at carbon 3. And at carbon 5, I have an ethyl. So now I need to put these in alphabetical order. We're going to go EFM. So it'll be 5-ethyl, 3-fluoro, 2-methylheptane. For the next one, again with the parent chain, count the carbons. I have 1, 2, 3, 4, 5, 6, 7 carbons. So I have another heptane. And I have 3 substituents. I have a methyl, a chlorine, and a bromine. So the way I have this numbered, this would be 3-methyl, 5-chloro, and 6-bromo. But what happens if I number it the opposite direction? If this is carbon 1, 2, 3, 4, 5, then I would have 2-bromo, 3-chloro, and 5-methyl. Now, because the green numbers, these numbers down here at the bottom, are less than the original numbers, my blue numbers, although we still have a heptane, I'm going to number the substituents this way, from the right. So we put this in alphabetical order. We end up with 2-bromo, 3-chloro, 5-methylheptane. Now we have a functional group. This time we have a double bond. We still find that longest carbon chain, hopefully that contains the substituent, or the functional group, in this case, the double bond, and we count the number of carbons we have in that chain. So here we have 5 carbons. This is going to be a pent, but it's not a pentane, it's a pentene. That E signifies that we have a double bond. Now, if I number from the left, that double bond starts right here at carbon 3. So that would be a 3-pentene. If I number from the right, however, the double bond starts here at carbon 2, We want to reduce that number. So this would be 2-pentene. The next one, again, with the longest carbon chain, finding that backbone. So we have 1, 2, 3, 4, 5, 6. We have 7 carbons, again, with the heptane. We have 3 substituents. This time they're all the same. So we would have 2, 3, 4. And this would be trimethylheptane. Now this should be an easy one. This is just 3 carbons. There are no functional groups. There are no substituents. So we would call this propane. Here we have 4 carbons. Again, no substituents, no functional groups. This is just butane. And here, count your carbons. Just 6 carbons, no functional groups, no substituents. This is just hexane. Now you may want to get into practice of calling this like N-hexane, N-butane, but that's not something that I'm going to need from you quite yet. So now let's work with some functional groups. The rules are the same. You find the longest carbon chain, the backbone or the parent chain, that contains the functional group. So here we have this functional group. This is an alcohol group. This alcohol group will give the ending OL. So we name the longest carbon chain as if it is a hydrocarbon. Then what we're going to do is take the E off and add OL. So this is butanol. But we can't just call it butanol. We have to say where that OH group is. So this is 2-butanol. This next one, I'm going to go down and then over. So this next one, we have 1, 2, 3, 4 carbons. So we would name it as if it is an alkane. And then notice that functional group. This is an aldehyde. So the aldehyde gives the ending AL, butanal. Now you don't need to say it's 1-butanal because aldehydes are terminal groups. They're always going to be at number 1, unless there's another functional group. We'll get to more functional groups here in a minute. This next one looks like propane down here. The backbone is 3 carbons long. So we would name that propane, but we have a functional group, and that functional group is a ketone. Ketones add the ending ONE, and we pronounce that own, not one. So we take off the E and then add the ONE, and that's propanone. Now the only way that propanone can exist is if the ketone is on number 2. However, to be thorough, we would put 2-propanone, just to get you used to numbering where your functional groups are. Now, similarly, we have this molecule, again, with the 3-carbon chain. We would name that propane. Notice the functional group. The functional group is an alcohol. Alcohol means we take the E off and we add OL. But we can't just call this propanol because we have to indicate where it is. It's either going to be on carbon 1 or carbon 2, and in this case, it's on carbon 2. 2-propanol would be the IUPAC name. Now, the common name would be to call this isopropanol. The common name of this is acetone. So these are the solvents that you were asked to buy to finish your kit. Now here we have what is called an ether. We have common and IUPAC names for ethers. Now the IUPAC name, just like the other rules, you find your longest carbon chain. Here we have 2 carbons, and I'm gonna change my color. And then here we only have the 1 carbon. See the oxygen in the middle. So because we have 2 carbons in our longest carbon chain, we would name this ethane. Then I would call this carbon 1 and carbon 2. We would name this bit as a substituent. So this would be called methoxy. So we would call this methoxyethane. That's the IUPAC name. The common name would be to name each arm of the ether and then add the word ether. So each arm means the left side here, that's an ethyl, and then the right side is a methyl, and then we would write the word ether. Ethyl, methyl, ether. And these bits get alphabetized. It's not left and right necessarily, it's alphabetical order. So that's the common name for an ether. Here we have, let's see, 1, 2, 3 carbons, and here we have 2 carbons. So the IUPAC name would then be to name the longest carbon chain, which would be propane. And then on carbon 2, we would name this as a substituent. So this would be 2-ethoxy. Yes, 2-ethoxypropane. To name it commonly, we would call this isopropyl. And then this group is an ethyl. Put those in alphabetical order. We have ethyl, isopropyl, ether. And there should be spaces between each of those. I'm just running out of room. So now we have a diether here, and that looks tricky, but to name it with the IUPAC system, we still find that longest carbon chain. And here it is 3 carbons long. And then we have our substituents. These 2 substituents, they are the same. So we would call this 1,3-dimethoxypropane. And that's all there is to it. It looks like a complicated molecule, but you still use the same rules. Find that longest carbon chain, locate the substituents, name the substituents, give them numbers, and write it out. So here we have a cyclohexane. And this cyclohexane has a methyl substituent. Now, because there is only one substituent, we don't really need to have a number there. If we had more than one substituent, we definitely need to have numbers. So this is cyclohexane, that is the parent chain. And then we have a chloro and a bromo. Now, I could call this 1-chloro, 3-bromo, because I would number this to decrease my numbers as much as possible. Or I could call this 1-bromo, 3-chloro. Well, when all things are equal, like the numbers would be the same, 1 and 3 is equivalent to 1 and 3, then I choose the number that would be the least for the highest alphabetical order. So this would be 1-bromo, 3-chlorocyclohexane. So now let's go up to some more challenging problems. Here we have an amine. So we would name this methylamine. Here we have another amine. Now, just like the other IUPAC rules, we find the longest carbon chain and name that. So this would be propane. But because we have this amine group, and we would call this carbon 1, this would be propanamine. And this would be a 1-propanamine. But what do we do with this methyl substituent? Well, we would call that methyl substituent an N-methyl. The capital N indicates that the methyl is on the nitrogen. So this would be N-methyl 1-propanamine. Now here we have a compound that has 2 different functional groups. We have an alkene, so we have a double bond, and we have this aldehyde. Now, typically when we would name an alkene, we would put E-N-E as opposed to A-N-E for an alkane. And then when we have an aldehyde, we would add the A-L. So which functional group is going to get the ending? Well, the answer is the most oxidized. In order to tell what the most oxidized is going to have the most oxidized carbon is the one that has the fewest carbon-hydrogen bonds. So we're looking for the most carbon-oxygen bonds. So the aldehyde is going to be the most oxidized. So we would look at this as a hexanal if we didn't have this double bond. Now again, that aldehyde group is a terminal group, so we don't need a number for it, but we do need to account for this double bond. So to account for that double bond, I need to change this AN for the ane ending to an en. And this time I need to give it a number. And that number is going to be 2 because it starts at carbon 2. So this would be called hex 2-en-al. So the next one, we have a bromine and an alcohol. We have 4 carbons, which would name it butanal. OL is an alcohol group. The alcohol group is at carbon 2. So this would be a 2-butanol. The bromine group is at carbon 3. So it would be 3-bromo-2-butanal. A common question I get is isn't it also correct to call it 2-bromo-3-butanol because the bromo comes first in the alphabetical order? And the answer is no. The functional group takes precedence, and the alcohol is more oxidized than the bromine. Therefore, it takes precedent. Now for this one, we still have to find our longest carbon chain that contains the most substituents and or functional groups. And here it is a cyclohexane, or it's a cyclohexene. So cyclohexene. And now we need to number to decrease the number of substituents and functional groups. So if I call this carbon 1, then this substituent and the double bond starts at carbon 1. Now, a thing to note with double bonds around cyclic molecules, the double bond is defined as being between carbons 1 and 2. So there are only 2 ways that you can number this. You can number it the way I have above in the blue numbers, or you could number it this way. Now, obviously, if you number it the way that I have on the inside, then the substituents are at 2 and 6. And that's much bigger than 1 and 3, so we would go with the outside numbers. I'm just going to erase those briefly. So we have 1 and 3. Now, we have a methyl at 3, so this would be a 3-methyl, and it would be a 1-ethyl. Alphabetical order, the ethyl comes first, so this would be 1-ethyl, 3-methyl cyclohexene. Again, because that double bond is defined as being between carbons 1 and 2, you shouldn't need a number there. If you would like to be thorough, you may put a number there. I'm not going to count you wrong for that. The next compound, again, find your longest carbon chain when you have a terminal functional group. Your terminal functional groups is you've got the aldehyde. This is the carboxylic acid. What's another terminal functional group? An amine, not an amine, an amide. When you have the carbonyl carbon with the nitrogen next door, that's an amide. That's a terminal functional group. Those don't need to have number signifiers identifying where they are. So here we have a 4-carbon chain with a carboxylic acid at the end. So we would name this butane, but because of that carboxylic acid, I'm going to erase the E and add oic acid. So this is butanoic acid. Then I need to name my other functional group as a substituent. An alcohol, when it is a substituent, is called hydroxy. So this would be 3-hydroxybutanoic acid. Here we have 2 functional groups. Let me see if I can give this a highlight. So here's a carbon, 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 carbon. Now I'm going to number this so that the functional group numbers are decreased. There are 5 carbons here. If I went the other way, then the double bond would still start at carbon 3, but the alcohol group would be on carbon 5, so that wouldn't make any sense. Now the alcohol group is more oxidized than the double bond, so it's going to get the ending. So we're going to start this with pentanal. If it was an alkane, that's what it would be called. But because we have this double bond that starts at carbon 2, I'm going to expand this just a little bit. And this would be a pentanal. And I have to indicate, this is where it starts to get a little bit tricky. So I have to indicate where these substituents are. So at carbon 1, I have the -al. And at carbon 2, I have the -ene. And it's a pent. So I would start by calling this pent-2-ene-1-ol. Now I need to name this substituent. So this is a 2-chloro-pent-2-ene-1-ol. Here, one that's a little bit easier. We have 2 carbons here. I'm going to start numbering it with the alcohol group. So we would call this ethanol. And this is a 1-ethanol, 2-bromo. And here we have a longest carbon chain. We have an aldehyde group. So 1, 2, 3, 4, 5, 6 carbons. So we would call that hexanal. This is carbon 1, so this is 4 and 5. We have a 4-chloro and a 5-hydroxy. And that's going to be the alphabetical order because C comes before H. So this would be 4-chloro, 5-hydroxy, hexanal.